Here we have a rational function divided by a rational function, and it's a bit more involved than what we've seen up until now. So you'll notice that we have a few terms, a few expressions that we need to factor beforehand. In fact, all these numerators and denominators have to be factored. So let's begin with the first numerator we see. We have that 10x squared plus 3x minus y squared. So we have this guy up here. I'm going to isolate that numerator and just factor that alone. So let me just copy it down. So I have 10x squared plus 3xy minus y squared. Now this is a complex trinomial, so I'm looking for two numbers that add to give me the middle term, which is 3, the coefficient that is, and that multiply to give me the product of -1, which is here at the front, although the one's not written, and 10, which in this case is -10. Those two numbers, -10, those two numbers happen to be 5 and -2. That works, and that works as well. So at this point, we decompose our middle term. So the 3xy becomes 5xy minus 2xy, and the ends remain the same. I have a plus 10x squared in the front. And now I can factor by grouping. So I'm just factoring my numerator of the first fraction. I'm going to isolate from here, bring out a 5x, and then I have 2x, and I have a plus y here. And from my last two terms, I'm going to factor out a -1. I'm left with, actually not -1, but -y. They both have a y in common. So -y, and I'm left with 2x plus y. Finally, I can rewrite my factored term as 5x minus y times 2x plus y. Now I'm going to take this. This is my new denominator of the first fraction. I'm going to copy it over. And I'm going to rewrite my original question, but with my numerator here in factored form. So what I get is something looking like this. So here's my numerator. My denominator, take a quick peek here. I have 9x squared minus y squared. Well, it should be clear at this point that that is a difference of squares, so I can factor it as 3x minus y and 3x plus y. And this is all divided by, well, my second fraction, I have a common factor in the numerator and in the denominator. So let's common factor those both before we write them out. So here we have divided by 3x, and I have 2x plus y, and in my denominator I have 4 and 3x plus y. Okay, so we've factored both numerator and denominators of both fractions. Step number 2 says to state any restrictions from the denominators and numerator of the divisor. So let's look at our denominators first. In my first set of denominator factors here, what can I omit? What can x not be? Well, if I have 3x minus y equals 0, that's this guy over here, then that means I get 3x equals y, which in turn means 3x cannot be equal to y. So that's our first condition. Our second condition, or restriction on the denominator, is very similar. I'm looking at this term here, and if you carry out the same process, same step of events, you find that instead of y not equaling 3x, you get y cannot equal -3x. And it turns out that the denominator over here, this factor, the 3x plus y, well, it matches up with the one we just did, so I don't have to list that again. Now we also have to take into consideration the the numerator of the divisor. So that's this guy up here. Remember, when we end up dividing, we're going to multiply by the reciprocal of the second fraction. So this numerator, I have to make sure that it cannot be 0 as well. Now there's two factors here. I have the 3x, and based on that, on the 3x alone, 3x will be 0 when x is 0. So x cannot be equal to 0. In the second factor here, the 2x plus y, if I have 2x plus y equal to 0, then 2x is equal to negative y. In other words, 2x cannot equal y. So here's all our restrictions. Let me just isolate them, pull them aside. So here's one. I'm going to copy that and paste it here. My other one is y is not equal to 3x. So I'll take that, copy it, and put it here. Get rid of this y. And then I have x not equal to 0. So I'll copy this as well and paste it over here. And then I have 2x is not equal to negative y. So I will copy that as well. Let me zoom in. Copy this and place it over here again. So those are all my restrictions. Now I can go about simplifying my expression. So I'm going to take the whole fraction, my first one and my second one, but I'm going to reciprocate it. So I'll take all of this, place it here, and instead of dividing, I am multiplying this fraction by the reciprocal of this guy here. So what that looks like is 4 times 3x plus y, close bracket, and then 3x times 2x plus y, close bracket. And now we're in a position to do some cancellation. Anywhere you see an identical factor in both numerator and denominator, even across fractions, you can cancel it out. So, for example, the 2x plus y up here cancels with the 2x plus y down here. The 3x plus y up here will cancel with the 3x plus y down here. And I believe that's it. No more other common factors. And our final line is just going to be the products of the numerators that are remaining. So in this case, it's the 4 and the 5x minus y all over 3x times 3x minus y. And there you have it. So there's your final expression. The restrictions are listed at the side here. And here's our reduced form. You may see in textbooks that sometimes they actually end up multiplying the denominator throughout, the numerator throughout, and just expand it, but they leave the denominator in factored form. Either way, they're both correct answers, correct forms.